Okay, so let us quickly go through the phasor diagram or the constellation diagram of this QPSK modulation scheme, right? From this phasor diagram or from this constellation diagram, what is the objective behind this graphical representation? We will come to know कि as we are having these four different D bits, which desired phase angle is being assigned to that particular D bit, whether it is 0, 0, 0, 1, 1, 0 or 1, 1. From that phasor diagram, it will come to know कि which desired phase angle is being assigned. So for that purpose, let us quickly assign a certain quantity which is present to the extreme right hand side of this horizontal reference axis. That is nothing but what denoted by the mathematical expression for this carrier signal root p into cos of 2 pi f naught t, right? Now obviously when this 90 degree of phase 90 degree is being added into this existing quantity, so obviously it will become what? It will become minus root p into sine of 2 pi f naught t. Again the desired angle for this quadrant is how much? 90 degree. So furtherly again 90 degree is being added to this existing quantity, so obviously it will become minus root p according to that basic theory cos of 2 pi f naught t, right? One more time, when we add another additive 90 degree to this existing quantity, so obviously it will become from minus root p into cos of 2 pi f naught t, it will become plus root p into sine of 2 pi f naught t, right? Immediately after that, what we need to do, we are supposed to draw the desired vector within each and every quadrant. This will be the first quadrant, second quadrant, third quadrant vector, and this will be the fourth quadrant vector, right? Now let us quickly define this particular angle for this first vector line, right? So the total angle for this quadrant is how much? It is 90 degrees. So half of that means what? How much it is? Obviously it is pi by 4. Now the question arises कि this pi by 4, this phase angle is being assigned to which desired d bit. How to decide that? So for that purpose, let us quickly go through the coordinate of this horizontal axis, which is nothing but what? Root p into cos of 2 pi f naught t, right? The coordinate of this y-axis is nothing but what? It is minus of root p into sine of 2 pi f naught t. Means here we used to have the positive value, within that vertical axis we used to have the negative value. So if we are having the positive, which is denoted by this 1, negative is denoted by 0. So initially we need to consider the quantity belongs to this horizontal axis, and after that we need to consider the quantity belongs to this vertical axis. So it will become 1 and 0, right? Which phase angle is been assigned to this 1, 0? Pi by 4. So we will come to know that this 1, 0 is being transmitted with the help of this phase angle pi by 4, right? Similarly, as far as the second vector is concerned, belongs to that second quadrant, its desired phase angle will be what? From this horizontal reference axis up to this point it is pi by 4. Up to this point obviously it will become 2 pi by 4, and up to this point it will become 3 pi by 4, right? So this 3 pi by 4 is assigned to which d bit here? Let us consider the quantity belongs to this horizontal axis. It is minus root p into cos of 2 pi f naught t. It is a negative value, so obviously 0. The quantity belongs to this vertical axis, again it is negative, minus root p into sine of 2 pi f naught t. Whether it is sine or cos, negative is being replaced with this 0, positive is being replaced with 1, whether it is sine or cos, so it will become 0, 0. So for that 0, 0, which phase angle is being assigned? 3 pi by 4. Let us quickly go through the vector of this third quadrant. Its desired phase angle will be what? From this horizontal reference axis up to this point it is 3 pi by 4. Up to this point it will become 4 pi by 4. Up to this point obviously it will become 5 pi by 4, right? So this 5 pi by 4 is assigned to which d bit? As far as this third quadrant is concerned, so the quantity belongs to this horizontal axis is negative, so it is 0, and the quantity belongs to this vertical axis is nothing but what? Plus root p into sine of 2 pi f naught t, means it is positive, so 0, 1. So for this 0, 1, which phase angle is been assigned? 5 pi by 4. The remaining d bit is nothing but what? 1 and 1. Why it is being called it is as a? Because see, the x coordinate is positive and the y coordinate is also positive, that's why it is being encoded as a 1. And the desired phase angle is how much here? Up to this point it is 5 pi by 4, 6 and 7 pi by 4. So this 7 pi by 4 is being assigned to this d bit called as a 1 and 1. So in this way these four different phase angles are being assigned to these four symbols for the purpose of transmission. Now the question arises ki how to represent these four different d bits with the help of this mathematical expression. So for that purpose let us quickly go through how to represent this 0 0, right? How that 0 0 is being generated. For that purpose the output of these two modulator is being added with each other, right? Here even bit is 0 and odd bit is 0, right? Means which quadrant we need to consider? 0 0 means second quadrant. So for that second quadrant the desired value is minus root p into cos of 2 pi f naught t minus root p into sine of 2 pi f naught t. And which phase angle is being assigned here? Up to this point how much? It is 3 pi by 4. For 0 1 how much it is? 0 1 means first x coordinate is negative, y coordinate is positive. This is x coordinate is negative, y coordinate is positive. So which d bit is being assigned? 0 1. So its overall value will become minus root p into cos of 2 pi f naught t plus root p into sine of 2 pi f naught t. The desired phase angle is how much here? 5 pi by 4, right? As far as the third d bit is concerned, which is nothing but 1 0. 1 0 means x coordinate is positive and y coordinate is negative. So this x coordinate is positive and y coordinate is negative. So 1 0, right? How to interpret this 1 0 mathematically? It will become root p into cos of 2 pi f naught t minus root p into sine of 2 pi f naught t. And which phase angle is being assigned? It is, which phase angle is being assigned? I think it is pi by 4, right? As far as the first quadrant is concerned, within that first quadrant which d bit we are having? 1 0. So the desired 45 degree means pi by 4. The remaining is nothing but what? 1 1. X coordinate is positive and y coordinate is positive, means quadrant number 4. Here how to represent this signal? Because representation is also one of the most important approach in case of this digital modulation and demodulation scheme. So it will become root p into cos of 2 pi f naught t plus root p into sine of 2 pi f naught t. And which phase angle is being assigned? 7 pi by 4. So in this way how this QPSK modulator works means these four different phase angles are being assigned to these four different d bits according to this constellation diagram for the purpose of modulation, right? Okay, so finally this is how the second approach involves in case of this QPSK technique is nothing but the process of demodulation, right? So the objective behind this demodulation is to what? Somehow we need to extract the desired binary symbol sequence which was given to the input of this QPSK modulator, right? What kind of input is being given to that QPSK modulator? As far as this QPSK modulator is concerned, first block involves in case of this QPSK modulation is nothing but bit splitter. So before this bit splitter the serial bit stream is being given. So our aim is to generate or to extract the desired serial binary bit stream at this end point of this demodulation process, right? So in order to successfully extract the desired modulating symbol sequence which was given to the QPSK modulator, here as you can see the two identical demodulators are being used, as we are having two identical modulators in case of that first stage. So this is nothing but what? The in phase demodulation, and this is nothing but what? The quadrature phase demodulation. This in phase demodulation works on the carrier frequency which is provided by this local oscillator. This quadrature phase component demodulator works on the 90-degree phase shift frequency provided by this 90-degree phase shifter. After this we used to have these two low pass filters, right? And after this low pass filter we are having these two square wave generators. And finally this odd and even bit are being demodulated at the same point with the help of this QPSK demodulator, right? So initially the QPSK signal, the received symbol sequence is being given to one of the input of this 2 demodulator, right? As I told you earlier, another input is nothing but the desired carrier frequency. Then it is being passed through these 2 low pass filter, which will try to block the high frequency component, and then it is being passed through this square wave generator. Means basically it will convert that signal in digital form, right? And once those signals are being converted into that digital form, then here in this upper part the odd bits are being demodulated, and in this lower part even bits are being demodulated, right? So this is how this QPSK modulation and demodulation works. Thank you.